For this concept check question, you're asked to draw both chair conformations of trans 1-bromo 3-isopropyl cyclohexane. And right now, when you're asked to draw the chair conformations from a name, you may want to start by drawing the structure using hashed lines and wedges, and that's perfectly fine. I'll start here today with the skeleton of my cyclohexane chair conformation. I'll number the carbons, and then I'll place the groups on each carbon. First, I'll place the bromo group in the 1 position, and here I can place it up or down. I chose up. And now when I place the second substituent, the isopropyl group, I have to place it down because the stereochemistry is indicated as trans in the name. I have to place the second group on the opposite side of the ring from the first group. Then I can do a ring flip and draw the other cyclohexane conformation. I need to number the carbons and make sure to keep the bromine and isopropyl groups on the same carbons. I also need to make sure the up pointing groups stay pointing up and the down pointing groups stay pointing down. So I always do that as a double check. In this question, you're asked to convert the chair drawings into flat drawings using dashes and wedges. I like to start by numbering the carbons and then making a note to myself to indicate if each group is an up or a down group. Then I draw the flat cyclohexane and number those carbons. When I number the ring, I'll be sure to number clockwise in both cases. And then finally, I can place the substituents on the appropriate carbons, being sure to indicate up group with wedges and down groups with dashes. For the second example, I'll go through the same sequence of steps, numbering the carbons and indicating the up or down nature of each group, and then placing them on the flat cyclohexane scaffold. Okay, here the methyl group is up and on carbon 4, and the OH group is down and on carbon 3. For the third example, again, I'll follow the same sequence of steps. I'll number the ring and then indicate up or down orientations for each group. Then I'll place those groups onto the flat cyclohexane on the appropriate carbon and with the appropriate stereochemistry. Here, a down ethyl group is on carbon 6 and a down chlorine is on carbon 5. In this last concept check question, you're asked to identify each structure as cis or trans. Here what we need to do is identify each group as pointing up or down, and then look to see if the groups on a ring are on the same or different sides of the ring. For this video, I'll also plan to redraw each of the chair conformations as flat, wedged, dashed depictions, but you may not need to do that, and that's okay. In the first example, the isopropyl group is up and the chloro group is down. This may be hard to see without drawing in the hydrogens on those carbons, so I'll encourage you to do that if you need to. I'll draw the flat cyclohexane ring, numbering the carbons clockwise around the ring. Then I place the substituents on the appropriate carbon and with the appropriate stereochemistry. Here we have one group up and one group down. They're on opposite faces of the ring, so this is a trans disubstituted cyclohexane. Now in the second example, we have an ethyl group up and an OH group down. They're on opposite faces of the ring, and so the stereochemistry is trans. In the third example, there are two methyl groups. They're both pointing up above the ring, so the stereochemistry here is cis. Finally, in the last example, we have a bromine group pointing down and a fluorine group pointing up. These groups are on opposite sides or faces of the ring, and so the stereochemistry here is trans.